Okay, so today we're solving 128 longest consecutive sequence. So you've got an input of a list of integers, and you're supposed to see which sequence of integers is the longest, and you've got to return that value. So for example, if we looked at this, we've got 1, 2, 3, 4, and we return 4. And in this example, we've got numbers from 0 to 8, which is a sequence of 9. The thing we have to understand here is there is also 100 and 200, which are sequences in itself, because this is a sequence length of 1 and this is another sequence length of 1. This is important to understand because we need to be able to segregate what is the beginning of a sequence, and how we can iterate from the beginning to basically count the sequence. We cannot, you may say, we can sort the array and then easily find the consecutive elements. This is a valid solution and it definitely works. But sorting an array takes has a time complexity of n log n. But we need a solution of O of n, and to get this, we need to use the concept of sets. So if I had to start coding this, this is going to be a return value of the longest sequence. Then we're going to have a set called numSet, and we can just convert the list into a set using this function. So now so we're going to do this twice. We're going to look at what happens if we iterate through a list to basically prove a point that lists are inefficient, although they hold lesser space, and you do not. So the trade-off with a list is, although it takes longer time to iterate through a list, it takes lesser space. But having a set takes more space because it uses specific blocks of memory, and that's what makes it extremely easy to access. And it takes retrieval from a set takes off one time. Anyway, so for num and nums, so here I'm using a method that's less inefficient. Sorry, a method that's more inefficient. And we're gonna initialize count equal to 1, and we're gonna check if num minus 1 is not in the num set. Then we know we have found the beginning of a sequence, and that's good. So then we can have a while loop. So while we're going to use a while loop to just iterate from the beginning of the sequence, because we have found that the we have found a number where that number minus 1 does not exist. So for example, 1 minus 1 0 does not exist. So we are going to start iterating from 1, and we're going to find the last element that exists in this sequence. So while num plus count, or to keep this simple, let me just write num plus 1 and then explain later. While num plus 1 is in the num set, we are going to keep increasing count. But if you notice this, I'm just incrementing it just by 1. So we're just going to see 1 plus 1 is 2, and then it's only going to check 2, and then it's going to get stuck in this while loop. So instead of doing num plus 1, we do num plus count, because every time this is true, count gets incremented by 1. So we can just add count to num, and we can just keep iterating until the next. So for example, 4 plus 1 does not exist in the num set. So, and then it gets out, and we can now change the longest value. But how do we know if the count value that we have just got from iterating through this sequence is the longest? We don't. So we're just going to use the max function, and we're going to check the maximum between the previous longest value and the one we just found using count. And this should ideally this should have your longest sequence of numbers, and we can just return this as return longest. And remember that I'm iterating through a list, so this is inefficient, and you will see why. Okay, I've indentation. Yep. All right. This should work. All right. So it runs, and you see that it takes about 4.3 seconds, which is a long time. And now with a simple fix, so with just using a num set instead of the array that I've got to iterate through, look at the difference. So remember, this is 4.3 seconds, and this is 351 milliseconds, and that's a huge difference. So that was the problem. Thanks for watching.